Right. Hello, everybody, and welcome to our last session for this topic on Euclidean constructions. We're going to use this application, GeoGebra, again in a future section, but uh, for this section, our goal was and is to use only the straight line tools, either a line segment or going through points, and a circle drawing tool, mainly the compass tool, to make various constructions. Just double check if my screen is as big as it can be. Yeah. Okay, so we've done a number of constructions. Let's remember the most important one, which is the perpendicular bisector to a line segment. There's my line segment, randomly. I can use the perpendicular bisector for a couple of reasons. I want a perpendicular line maybe, or I want to cut the existing line segment in half. Either way, or both maybe. Either way, the perpendicular bisector construction will do either or both of those things. So let's suppose I want to do it on this line segment. I'm going to look for a point because this GeoGebra application needs another point. For my compass tool, I'm going to go from A over halfway, comfortably over halfway, maybe over there. Don't be too close, be well over halfway. Then I'll go to my compass tool, and I know you've mastered these, just in case someone watches the video, a little intro, a little review. I don't have enough to fill a whole hour today, so I'm trying to fill this. I'm going from the outside of my circle to the center, confirm. And then I'm going to copy this circle and center it at B by just drawing it again the same way I have. Without confirming, I can float it over to B. This then gives me 2 points where these two circles intersect. Now, if you're doing this by hand with an actual physical compass, then you only need these arcs, right? You don't need a full circle. The backside of the circle is irrelevant to me. But GeoGebra doesn't have that option. It's always going to be full circles, so there it is. And then I can draw a line segment between these 2 points. Maybe I don't want to see these circles because they were just there to find the 2 points for me. Now their use is over. There is my perpendicular bisector, cutting the line AB in half, also giving me a perpendicular line to the existing line. Sometimes I need both. Okay. So again, I will say that if you are watching this after the fact or right now, live, if you have not mastered this construction, stop, don't watch further, go back and master those previous 2 sessions first. You're doing yourself a favor, even though it feels like, no, I don't want to waste time. I want this session. No, you don't. You don't. We need to build this up correctly to avoid frustration. I'm going to remind you of another construction as well, which is given an angle like this. Let's look at the acute angle. It doesn't have to be acute, but that's intuitively a nicer one to work with. I want to find a line through B that cuts this angle in half, the angle bisector. We haven't used that too much, so let's, oopsie, not a point. So let's just review that one, because it might be important for a certain problem that we will do soon. Okay. How do I do that again? Ooh, I don't know. Let's take another point. It can be the endpoints of the line segments provided, but if that's too big for you, pick something nice and comfortable. Maybe over, let's just do point, maybe over there. Maybe that's a nice distance from B. That's comfortable for me, especially when you do it by hand. You don't want that compass to be too big, too wide, too small, comfortable to make a nice arc that doesn't wobble in any way. All right, so now I want to go to my compass tool. I want to make a little circle with that radius. There it is. To find the other point for that circle intersecting the other line segment, calling it E in this case. Now I can take the same circle, doesn't really matter what circle, but let's pretend I make a new circle and I can use the radius DE is usually quite comfortable, but know that it can technically be anything. Make a circle like that. Then I'm going to copy that, moving it to center D, doing the exact same thing, moving it over so that I can find a point where those two circles intersect. As long as those two circles centered at D and E have the same size, same radius, I'm good. Could be very big, could be very small, doesn't matter at all. There is my line, BF, and maybe I want to hide some stuff. Hide that circle I should have hid previously. I don't need any of that. It's all irrelevant. I'm looking for a line that cuts the existing angle in half. There it is. Angle bisector. So in a test, let's talk about a test. What should you be able to do? I could ask you these constructions, these intermediate constructions on their own. I could say, make an acute angle and then construct an angle bisector for that angle. Or I can give you a picture or whatever, right? So you might have to just do this. Or I give you a line segment and I say, construct a perpendicular bisector to the given line segment. Then that's all you do. And then you, of course, you can gray out your work, but you do want to show it. Move it nice and centered over here. Show the work, submit that, you're done. Or it could be part of a larger construction where you would use these intermediate constructions repeatedly to make something bigger. And we've done that in the previous session. Let's go back to the previous session. I'm not going to do them again. We have done them. They're not uploaded yet. They should be under the live section. I have uploaded it while I was sleeping and I just got stuck at 60-something% when I got up this morning. So sometimes the files are really big and YouTube gets a little stuck with my wonderful information that I have. So what we have done previously is we start with a circle like that. The circle is given, or in our case in GeoGebra, we just start with it. Now it's given. Our goal last session was to construct various regular polygons inside the circle so that their vertices are on the circle. So then if that is the question, then of course there are many intermediate constructions to perform in a sequence of steps on the way to making that end polygon. Honestly, I don't really care which one you use. I didn't want people to feel forced to buy a geometry set if they don't have one already. And it wasn't as easy for me to record and talk with a camera on my hands. It didn't seem quite as efficient. So I opted for this, which is the best one I could find. But now, honestly, that I've used GeoGebra, I am not going back. This is just too nice. I'm not using it by hand anymore. I'm teaching it like this forever from now on. Because it's free, it's accessible, but I don't want to limit you. If you want to do it by hand, go nuts. And just like you're writing your answers by hand, scan it in with your answers. It's all good. It's the same result, right? We've shown how you can download this as a PDF and then merge it. Maybe we can do that again in this session. So because I want you to submit a PDF, ultimately this just works in line with that. In a face-to-face class where you're going to get a test paper and you write by hand, yeah, maybe a geometry set does make more sense. It fits with how you're doing it. But don't feel limited in any way. My most important thing is I need to see your work. I need to see all the little circles and things you've drawn on the way. That is the most important. To verify that you've actually used only a straight line and a compass tool. Right? That could be a physical or a digital tool, electronic tool. Doesn't matter to me. Okay. So we've done these. I'm not doing them again. Review them. There's a live video, and I'll upload the video again once the internet wants to work with me. I want to go to some of the problems because no problems? Problems. Because in this section, me doing problems for you, it doesn't ruin anything. Previously, sort of, if I do a Venn diagram question for you, it kind of ruins it, right? You need to go through that puzzle aspect yourself. Here, it's very much a question of understanding what we need to do and then practice doing it and then duplicating it in a test. So I'm not really ruining anything for you. And especially the first two problems, which are the most important ones, they are maybe a little difficult to understand, and one of these pictures do not line up with the words. So I thought it best to have a session to just do problems 10.1, 10.2 at the very least. And then the other ones are just extensions of those, which you are welcome to do on your own. But these two might not be the simplest. Okay. So let me just check if I want to do the first one. Yes, I want to do the 10.1 first. Let's read it together. Don't pay attention to this picture. You see they're the same picture? It shouldn't be the same. Draw a large triangle on a piece of paper or whatever, right? Start with a large triangle. Our goal is to... Actually, I'm just going to do it like this. That question is way too wordy. I will read the question in a second, but reading words, it's kind of boring. Let's start with a triangle. Actually, I have a polygon tool here, which makes the polygon nice and sort of cohesive. Shaded in and blue, and it's nice. Okay. There is a triangle. I want to put a circle around it so that the vertices are on the circle. It's just a reverse question. Instead of starting with a circle and putting a triangle in it, I want to start with a triangle and putting a circle around it. We circumscribe a circle. Circumscribe a circle. The nice thing about a triangle is that I can do that with any triangle. Larger polygons, they have to be regular for me to do that. Triangle, I can start with anything. It doesn't have to be regular. So let's just read that. How do they suggest we do this? Construct a perpendicular bisector of each of the three sides of the triangle. Okay, we know how to do that. If you constructed them correctly, they should all intersect in a single point. Okay, we'll see. This point is called the circumcenter of the triangle. And then measure and compare the distances from the circumcenter to each of the vertices. They're all the same. Use that as radius. Construct a circle to pass through all the vertices. Wow, one thing at a time. That was a lot of words. Start with my triangle. That is what I start with, triangle. The way I'm going to circumscribe a circle, circumscribe means outside the triangle through all the vertices, is by drawing a perpendicular bisector for each of the sides of the triangle separately. So I'm going to do the perpendicular bisector construction 3 times. 3 times. Center it there nicely. Okay, so let's do AB first. Doesn't matter which one I do. AB first. That's my line segment. I don't care about this line segment. I don't care about that line segment. This is my line segment as if it was the only thing there. I need to draw a perpendicular bisector. So I'll go from B over halfway. Boom. Something comfortable that I know visually is over halfway. Go to my compass tool. So these are, yes, they're problems. These are constructions you have to know how to do. They're just as important as the previous session. They just happen to appear in the problem. If I take the time to do them, they are important. Circle, there, done. Then I copy the same circle to the other side. That gives me 2 points. Just like the perpendicular bisector construction every single time. Make a through line, make not a through line, I don't care. Let's make a through line this time. Mix it up a little bit. Actually, you should always do a through line because your point might be short, depending on where you put your D point, might be far, I don't know. So through line might be helpful to cover all possibilities. There's my perpendicular bisector EF to the top left side of the triangle. Now, for my benefit, which makes GeoGebra just so nice, I can hide all of this that I don't need to see anymore. I only need to see the line. Now we move on to the next line segment. Let's go for AC, and I do the same thing. Let's go from A, for no reason whatsoever, pick a point over halfway. That one looks pretty good. Make a circle with radius AG, centered at A. There it is. Copy that circle to be centered at C. I'm just going to backtrack a little bit. I want my circle to be a little bigger for no reason whatsoever. Just so the center here is not too crowded. That is the only reason, because it's our first example. Okay, so I'm just going to pick a point that is a little bit further away. No reason whatsoever. Not that the other one wouldn't have worked. I just don't want things to get too crowded. There we go. Oh, just coincidence it goes through F. Don't look at that. That's got nothing to do with anything. Copy it over, move it to the other side. It doesn't matter how big your circles are as long as you go over halfway. But because I know what's coming, it's a little bit nicer if things are a little bit bigger. Just so the center of the triangle doesn't get too crowded and I forget what I'm doing. That I will, but these things help. There we go. This perpendicular line does not have to go through the opposite corner point of the triangle. Only when it's an isosceles triangle will that actually happen. And the chances of me drawing an isosceles triangle freehand, that seems unlikely. So I don't expect that. That doesn't bother me in any way. I'd be shocked if it does perfectly go through B, honestly. All right, so these points don't actually matter. I don't think I can hide them. If I hide them, does anything happen? Oh, no. Okay, so let's hide them. I don't need the labels for those points. They were just used to get my line. So now it's nice and clean. Do I even need this G guy? Probably not. Be gone. There we go. Oh, so pretty. So it's hard to eyeball if this is perpendicular when the line segment is slanted. It's tough. It's tough, which is why I need a construction. Now our last edge is this BC edge. Don't be distracted by these existing lines. They're completely irrelevant. Let's go from B to maybe that point J, just over halfway. I'm making it bigger so I leave the center as clean as possible. Doesn't have to be. It's just a nice rule of thumb. You could make it closer to halfway. Doesn't matter. Then I go circle with radius BJ. Copy that circle over to be centered at the other endpoint of the line segment. I'm gonna have to zoom out. Maybe my circles are too big. No such thing. Then I will look for the intersections of those two circles. I will connect them with a line, which is my perpendicular line to BC. A lot of things are happening here. I don't necessarily want to see them all. Get rid of that circle. Get rid of that circle. Get rid of that point J. Get rid of this K and L too. They were only there for me to draw the perpendicular bisector. Now I have it. It's over. Move on. Zoom in as much as I can here. It's hard when get used to this application, it's hard to do everything by hand again. There's no risk of making a small little wobbly compass error. Look how perfectly they intersect, just like the description said they would. And if they do not, then one of these perpendicular bisector constructions, something went wrong. They need to perfectly intersect each other. Now, I'm looking for a circle. If I measure this point, let's make the point proper. Point M is going to be the center of my circle, and the distance M to A, M to C, M to B are all the same. And the radius of the circle that'll wrap around this triangle. I can use the compass tool again, sure. Compass tool. Outside to center, right? Outside to center. Look how beautiful that is. Confirm. I have other circle tools as well. Maybe this is a good time to explore them. Circle with center. This first circle tool. It's in my basic tools as well. I think this one goes from the center out. What's nice about this tool is I can see it expand. I get closer to all the points. Pick any one of them. Pick that one. Or pick C. Pick B. I like the real-time expansion. I like that. But the result is the same, right? So now you can actually hide all your perpendicular lines if you feel like it, just to look at it. So beautiful. But of course, when you submit it, show everything. I want to see them all the work you've done. Look at it. Seems like a lot when you look at the whole picture all in one. But systematically, I looked at each line segment, perpendicular bisector. Same construction, perpendicular bisector, perpendicular bisector. So it was built on only one thing, really. Looks much more impressive than it actually is. So this is how we circumscribe a circle around a given triangle. Now the later problems ask, what if I didn't have a triangle? What if I had a rectangle? Can I still circumscribe a circle? Would it work for a parallelogram? Other larger polygons? And you'll see that if I have, if I have too many sides, it's not going to go that well, unless it's regular, but something to explore. And there are answer keys where I drew them all anyway. The most important thing that you have to be able to do will stick to a triangle, because then the benefit is I can have any triangle. Let's have a weird triangle. Let's make it weird. I judge triangles, but let's make it less common, like that guy. That might be isosceles. I don't want to have any special case triangle here. Let's go with that guy. That guy's better. Not that the other one would have been wrong. Let us do the same thing again. And I mean, it's good practice. You want to practice those perpendicular bisector constructions anyway. So, not a big deal. Let me just move a little bit. I'm going to go to line AB. Perpendicular bisector for line AB. Let's go from A to B. Nice and tight this time. That's over halfway, pretty sure. Get a circle going with my compass tool, center it at A, then copy, not move, one centered at B, gives me 2 points, just to show it can be small. I'll get a through line, like so. Now that I have my line, I'll hide it. Boom. Don't need labels, don't need anything. Then I'll do the same thing for BC. Pick a point from B, let's say. Let's make it just over halfway. Doesn't matter. Not there. No. Let's make it big. Why? Because I feel like it. Mix it up to show you it doesn't matter as long as it's over halfway. That's a lie. I know exactly what I'm doing, but you don't need to. I just want things to not get too cluttered in the wrong places. Then I'll copy my circle to be centered at C. As long as that circle is the same radius, it is all good. It has to just be over halfway. Get 2 points, make a through line through those points. That's my other perpendicular bisector. Does it look perpendicular and a bisector? I don't know, because these other things confuse me. The G confuses me. The circles confuse me. I don't know exactly. I can't eyeball it, which is why I have the construction. Take the guessing out of it. There it is. Now I'll just move around a little bit here with my move tool, because this line segment is a little longer, maybe over here. So this AC needs a bisector as well. Pick a point from A over halfway. Let's go blah. That. Then draw a circle centered at A. Confirm. Centered at C. Right. That gives me 2 points. So these bigger constructions do help me practice the perpendicular bisector. So there are benefits as well. Let's hide some stuff. See, if I saw all the other circles, it would have been very distracting. I do need to show them, even though faded out, for test answers. But look how many lines there are. When I still need to draw stuff, I don't want to see it necessarily, which is the benefit of doing it electronically. If you did it by hand, you have to look at all those circles and things you drew. But then you have the benefit of just drawing little arcs, not full circles. So pros and cons. There's my center, my circumcenter. Does it make sense to be outside? Yes, it does. Yes, it does. Just because of the shape of the triangle. Just because of the shape of the triangle. Circumcenter does not have to be inside. It can be outside. I drew a circle around the triangle with all the vertices sitting on the circle. Okay. So the nice thing about a triangle is it doesn't matter what triangle I start with. It'll always work. Because 3 points uniquely specify a circle. If I have a larger polygon, well, now the vertices are more than 3 points, and things can get a little messy, because not any 4 points will necessarily sit on the same circle. But if it comes from a regular polygon, then it will as well. But then I'm just forced to do the perpendicular bisector construction over and over and over and over for each side of the polygon. If I could do it 3 times, I could probably do more. So I'm happy to stick with the triangle. All right, that was one. It twice just to show the triangle does not matter. Let's make another triangle. Let's make it not too. I think that's. Oof. Who cares? Random triangle doesn't matter. Okay. So now my last construction is do not put a circle outside or around the triangle, but put a circle inside it. Inscribe a circle. Okay, so I have circumscribing a circle and inscribing a circle. Circle inside, that'll just touch the edges of the triangle. Sitting inside the triangle, but being as big as possible. How do I do that? It's actually very similar, but instead of drawing perpendicular line segment bisectors, I'm going to bisect the angle. Construct the bisector of each of the 3 angles. That's all I'm going to read. I don't need more. Thank you. So when I'm trying to put a circle inside a polygon, I have to bisect the angles. So let's do it. Let's start with the bottom one. Why not? Work my way up. Maybe I want to zoom in a little bit. Care about the other. Right now I'm looking at this interior angle and I need to bisect it. How did we do that? Oh no, if only I reviewed it in the beginning. Oh wait, I did. What's this point doing here? Be gone. I want to pick a point. It doesn't have to be over halfway. Anything, just pick a comfortable point. Let's make it actually nice and small. That one looks pretty good. Then I'm going to make my little circle. That gives me a point on the other line segment where the circle intersects. Now, I think it's a good habit to stick with, it doesn't really matter. You can pick any size circle. You can pick the same circle. You can pick radius DE. I don't care at all. Let's pick the DE one. Circle. Then I want to center it at D. Regardless, that gives me a point there. Make a through line. BF is my angle bisector. Maybe I don't want to see all of this, right? It was only there to get the bisecting line. Now that I have the bisecting line, I don't need any of it. Be gone, labels. There we go. Let's move to the C one, maybe. I have to bisect that one. Let's do it. What do? I pick a point that's comfortable, maybe that one. G. Doesn't care about halfway or anything. I just make a point. Whatever's comfortable to draw your circle. I will then draw my circle centered at C with that radius. That gives me another point where the circle intersects the other line. Then I will use that GH radius. I don't have to, but it's comfortable, it's there, why not? And then again to the other center. It's a coincidence that they almost go through C. Doesn't have to. I'm only looking for one point, and it's that one. Where those two circles intersect, that gives me my angle bisecting line. This is going too fast. Then remember you have a video backup you can watch over and over. There we go. Another one done. It's the same construction over and over and over, which you have supposedly already mastered. Right? Right? Yes. Last time, bisecting this top angle. Pick a point, any point, this point. Not that point. That point. Make a little circle with that radius. Oh, it's so tiny. That gives me another point on the other line segment. Then make a circle maybe with that radius, kj, centered, at j. And then again centered at k. Same circle, that has to be the same circle. That gives me another point where the circles intersect. Make a through line, boom, boom. And that bisects the angle for that angle. Let's hide some stuff that I don't want to see because it might distract me. There we go. Let's zoom. I don't have to zoom out. I think I'm good. There we go. There we go. Now, I don't want to do too much more. I know this is the center of my inscribed circle, but it is a little tricky to construct that circle by hand because it doesn't go through points that I currently have. It's just going to touch the side, not at this point necessarily. It's just going to touch the side of the circle. Not the circle. It is the circle. It's going to touch the side of the triangle. And if I do it by hand on paper, it's a little tricky to measure my compass. Well, how far do I go? Luckily, with GeoGebra, it's much easier. You go from the center. Let's go to the side here. And just see how far can I take it until it touches. Now, it snaps a little bit, unfortunately. But there we go. See, that's probably as big as I can go. And I just stop. Wherever my hand is, I don't care. So it's very nice, the circle with center tool, to sort of cheat a little bit, but hey, why not? So that I can see the circle expanding until it touches the side, and it's going to touch every side perfectly at the same time. When I have to pick a point, if I didn't see the circle, how do I know where it touches? Is it there? Is it there? Is it there? Is it there? It's a little tricky, and I would have to do some other work to really be sure, and that gets unnecessarily complicated. I don't want that to be the focus. So when you do it by hand, you sort of have to guess a little bit and eyeball it. We know it's there. We know this is the circle. We know it's going to be perfect, but how big is the circle? Well, another benefit of doing it electronically is you can just let it dynamically expand. Touches beautifully, and then commit. That point is just there because of the tool, and it's perfect. It's beautiful. So you see here, it doesn't have anything in that sense to do with the bisecting angle lines. That's not where it touches. Sometimes, and in the case when I have an equilateral triangle, a regular polygon, that point where the bisecting angle line intersects the opposing side of the polygon will be where the circle touches as well. But my triangle was not regular. I can't freehand a regular triangle, so I couldn't really use that. Sometimes it's far off, sometimes it is pretty close, but I can't really trust it, right? If you have a regular polygon, regular triangle, well then everything is perfect. The structure is as nice and symmetrical as you can possibly imagine. And then all these things sort of line up perfectly. So we have circumscribing a circle. We have inscribing a circle. Circumscribing outside circle requires that I bisect the sides, and where those lines intersect will be the center of my circle. Inscribing a circle is where I bisect each of the angles, and where those lines intersect, that's the center of my inscribed circle. You can see here that if I go to a vertex, they don't all sit the same distance from the center. The circumcenter is not the same as the, what is it even called? Inscribed center? I should know this. You know it has a name. Oh, the in-center. It's not a word I use often. The circumcenter is not the same as the in-center. The center of the circumscribed circle is not the same as the center of the inscribed circle. A fun little exercise would be to draw both at the same time. One circle sitting inside, one circle wrapping outside, and you see they're not concentric circles at all. They're going to be off in some way. But regardless, that is our last major construction. That's problem 10.1. 10.2, don't pay much attention to the drawing here. Actually, this drawing is appropriate for 10.1. It was accidentally copied to 10.2. This is not the drawing, right? This is a circumscribed circle. That's not what we're doing in 10.2. So don't let that confuse you. And I'm going to leave these problems 10.3 and 4 up to you. It's a little more work because in 10.4, if I want to inscribe or circumscribe, I can do that with a larger polygon, but it's going to have to be regular. And I can't freehand. I have a polygon tool here. I can't freehand larger. I can't freehand a square even. It can't just look. Oh, I do have a tool here. Look at this guy. Ooh, that's nice. That's nice. First time I discovered that. I haven't bothered. Where's that regular? I have a tool here in GeoGebra that I can draw a regular polygon. Otherwise, I would have had to use my previous session's instruction. Start with a circle, put a regular polygon inside it, then I can inscribe a circle into that, which you'll see is how I did it on paper because I can't freehand a regular polygon. But technology saves us once again, and we can sort of skip that first step to just get a regular polygon. Select 2 points, then Enter the number of vertices. Oh, all right. Let's go 5. Ha, sweet. Let's just move that around a little bit. Look at that beautiful thing. Regular. Now, of course, it's a lot of work. I'm not going to do this for you because it's the same construction over and over and over, which is why I won't make it very big. Even this, it's unnecessary. It's just time consuming. Can you bisect this angle? Of course I can. Can you bisect that angle? Can you bisect that angle? It's the same construction every single time. You'll get a center, and you can then inscribe a circle. You'll get the same center, actually, if you were to circumscribe the center. Now, you'll see here that GeoGebra does have some shortcuts because those instructions are so familiar, and those shortcuts we may use some of them in a future section when we're doing transformations. It has a perpendicular bisector tool. Select 2 points or 1 segment. Let's pick this one. Boom. Bisector. But you have no work that you can show. It doesn't count for the test. Doesn't count. You'll get 1 for understanding what the question is asking, but you get none of the other points because you didn't use just a compass and a straight line tool. You used a tool in GeoGebra that does all of those things in the background for you, and there's no work to show. However, to speed things up now, I can just quickly find it over and over and over, as if I took 20 minutes to do it. And you can then see, oh, boom, there is my circumcenter. Let's pick a circle. Let's make it pretty. And it goes through every point as it should. Now let's hide these lines. Do not be confused. I am simply saving time to show you a bigger polygon. I can bisect an angle. I can bisect an angle as well, just to speed things up. This is not going to give you any marks on the test. Well, it gives you 1. For participation. Angle bisector, select 3 points or 2 lines. Okay. That's a line. That's a line. Bisect it. And it does some other things in order to do that. That's a line. That's a line. Bisect it. That's a line. That's a line. Bisect the angle. That's the line. That's a line. Bisect the angle. That's a line. That's a line. Bisect the angle. You see that the previous point is the same point. But now, of course, I want to inscribe a circle. Same center, go out to the edge. Like I said, it touches at the same place where the perpendicular bisector was, the halfway point on each line segment. I can hide this perhaps. Maybe I don't want to see any of those lines. Hidden? Sort of. I don't want to see these outside ones. They were just extra that GeoGebra thought I wanted. I did not. Go. There you can see. Circumscribed circle, inscribed circle. We used the shortcut tools simply to save time, to show that in a regular polygon, the circumcenter and the incenter is the same, and the 2 circles are concentric. In anything other than a regular polygon, it might not even be possible, and if it is possible in the case of a triangle, the circles won't be concentric like this. They will have different centers and all kinds, different radius and all kinds of things, right? So please don't be confused. I use the shortcut tool simply to save time. This is not showing your work. Perpendicular bisector has its own construction. Go over over halfway, circle, circle, connected to intersecting points on the circle. That is your work. This is not it. I will not give you any more marks for using the shortcut tools in this section, because the question will say use only a straight edge and a compass, which means you can only draw, the only tools you can use are straight line drawing tools, segment or through line, and circle drawing tools, compass or circle with center that expands to make the inscribed circle a little bit easier. All right, that is the end of this section. It was a long one, but I thought it was a fun one. I had fun. Are there any thoughts or questions about this? Lots of things to practice. No questions. Speechless. I understand. I understand. You just can't wait to get to the practicing. You just want me to stop talking. Okay, fair enough. I will stop talking and leave you to it until next time. See you later.